Okay, now we will see another question here. Just a minute, I will start the slideshow. Yeah. Take the square cross section of the beam and the diamond cross section of the beam. Just a minute, we will not see the question properly. Yeah. Now tell which one is better for the bending stress. Okay. Now here we will consider both the cross section. First, we will consider a square one. Just a minute, I will draw. Let's say side are A, and we will consider diamond here. Sorry, sorry, I'm not that good at drawing. Okay, telling you. Okay, okay. So yeah, A. Now, moment of inertia for both square and diamond is same, which is equals to A raised to power 4 upon 12 power 4. Okay. Now, as per the flexure formula, sigma is equals to my by I. Okay. Now, the moment will be same for both square and diamond. Okay. And I is also same for both the cases. Okay. But now the major problem will arrive due to the Y. If we keep in the diamond position, it will be like on it will be on diagonally from the neutral axis to the outer section. And it will be, this is per se A and A. So this will be root 2 times A. And half of it will be, uh, just a minute. Yeah. A by root 2. Okay. So this distance will be A by root 2, which is equals to Y2 in this case. And for the square section, it will be uh, 0.5 times A. Now here we can see Y2 is greater than Y1. Therefore, induced bending stress will be greater for diamond than square one. Hence, we will go for square section as we want to minimize the induced bending stresses. That's why. Okay. Now there was one, counter question to this. They were just asking the basic. Sorry, not this one. They were asking to draw the shear stress variation in square cross section B. Don't just say square cross section. Okay. So if we consider here, as we all know, it will be not in the linear or fashion. It will be in a parabolic fashion. And this is due to, we can check it by VQ over IT. It is V is the shear force, is the upper area into Y bar upon I into thickness T. Now, if we consider this distance as C and C, okay, and for any particular Y from the neutral axis, the tau at Y will be given as 3 by 2 shear force upon area 1 minus Y square upon C square. So this will be the formula or equation to calculate the shear stress. Okay. Now one more counter they have asked to this. They're just checking the basic understanding of the shear stress and bending stress. I will change the color here. Let's take blue. They're asking to draw the shear stress bending stress variation for a square section. As we all know, it will be, if we consider a sagging moment, we will consider a sagging moment here. It will be simply like maximum at the outer section. From that, it will become zero at the neutral section, and it will go on increasing till the lower outer section. The direction it will just reverse here. Okay. This was a pretty simple and straightforward counter question which was asked. Thank you.